So first, let's find the price using the Gordon constant growth model. First, we need to find the discount rate, the rate of return on stock. For this, we'll use CAPM, the capital assets pricing model. CAPM says that the rate of return on stock is equal to the risk-free rate plus the market risk premium times the beta of the stock. Remember, the beta is just a multiplier that relates the risk of the actual security to the risk of the market. We are given all these numbers. The risk-free rate is 3%, the market risk premium is 10%, and the beta is 1.2. So we plug them into CAPM, and it gives us a rate of return on stock equal to 15%. The Gordon model views a stock as a constant growth perpetuity. The dividend in period 0 was $2, and it's expected to grow at a constant rate of 5%. So we use this formula to find the price in year 0. Remember, we need the dividend as of year 1, and we divide it by the rate of return, the discount rate R, minus the growth rate G. So we get the dividend in year 1 by multiplying the dividend that just happened, the $2, times the growth rate, 1.05, and this whole expression in the numerator is equal to D1. We divide that by the discount rate, 15%, minus the growth rate, 5%. We get a price in year 0 equal to $21. So that's the price of the stock that has 5% growth using the Gordon constant growth model. To use the Banko model on the stock that has a constant growth of 10 cents, we need to split up the cash flows. So the $2 began in year 0. We don't get that cash flow, that's just used as a reference point. And it's growing at 10 cents each year. So in year 1, there's a total of $2.10. In year 2, $2.20. But as we can see, we've split it up into its constituent parts. The original $2 dividend is still present in each year, so we're just splitting that up into this top row. This 10 cents is earned in the first year. This is the first growth of 10 cents. Well, in year 2, the whole stock is worth $2.20, but the original 10-cent growth from year 1 is still there. And it'll be there every year, starting in year 1 all the way out to year infinity. Same with the 10 cent that comes in year 2. That'll start in year 2 and it'll go out to infinity, and so on and so forth. So we can see by splitting up these cash flows into these different rows, we just basically have a bunch of perpetuities. So first, let's find the present value of the stream of $2 cash flows. This first row right here, these $2. Well, we'll use the present value formula, which says that the price in year 0 is equal to the dividend in year 1, the $2, divided by the discount rate, 0.15%. So we do that, and we see that all of those $2 cash flows are worth $13.33 in year 0, because again, we get that present value 1 year before the first cash flow. Now let's convert each stream of 10-cent cash flows into a single value. So we'll use the same equation, but now our dividend in year 1 is the 10 cents. And we'll be doing this for all of these cash flows. It's not necessarily important that the dividend be in year 1. It's just that the dividend is going to be 1 year in front of wherever the value that you get, the value that you evaluate all those dividends at. So when we evaluate this stream of cash flows, we'll get the value as of year 0 because it's 1 before the first period. These cash flows will be evaluated as of year 1 because it's 1 period before the first cash flow, and so on. So when we take the 10-cent payment, the 10-cent growth, and divide it by the discount rate of 15%, that gives us a present value of 0.667, about 67 cents. And so again, those are all going to be, for those separate cash streams, evaluated the period before the first cash flow. So we've just erased all the original ones. Now we've boiled the problem down to the original $2 stream is worth $13.33 in year 0. We have another payment worth 0.667 in year 0, and we have one in year 1, and we have one in year 2, and so on and so forth. We have one in year 3, in year 4, and year 5. So what we're going to do now is just move up the ones that start in year 1 all the way out into infinity into a new row of their own. So now we have created this new infinite stream of cash flows, each cash flow of which is 0.667. So we have a new stream, and we're going to use the same perpetuity equation on this one to simplify it. So we're going to ignore this 0.667 because it's already in year 0. We don't need to include it in this valuation. We're going to start with the one that occurs in year 1, and we'll find the present value of all of the others this whole perpetuity. And again, this will give us this value evaluated as of year 0, since that's one period before this first cash flow. So we use the equation, we take the 0.667 divided by the same discount rate of 15%, and that gives us a present value of $4.45. Again, that's as of year 0. So now we've boiled down all the cash flows to these three numbers, all of which are in year 0. So we have these three values in year 0, and we can add them up to find price. So the $13.33 plus the 0.667 plus $4.45 gives us a price of $18.45. So the difference between the two prices, the one using the Gordon model and the one using the Banko model, is $2.55, and that's the answer to this question.